Enceladus is the sixth largest moon of the planet Saturn. With a diameter of just over 500 kilometers, the surface of Enceladus is covered in water ice. During 3 flybys of a spacecraft called Cassini in 2005, they noticed heat escaping from the inside of the moon and from its south pole. This exciting observation makes Enceladus the third known planetary body, after Earth and Io, to emit enough heat to be detected. Using an instrument called the Composite Infrared Spectrometer, or CIRS, the spacecraft detected temperatures in excess of 145 Kelvin, or negative 128 degrees Celsius here. The surface of Enceladus is only negative 198 degrees Celsius, so there must be internal heating to produce these higher temperatures at the South Pole. Interestingly, the temperature only seems to increase below 70 degrees south latitude as you approach these south polar jets.
At the South Pole, there are 4 large cracks, or sulci, cutting across the surface of the moon. These are also known as tiger stripes. These jets appear to emanate from these tiger stripes, based on the similar widths of both the tiger stripes and the plumes. The material inside the plume is composed of gas and dust. The cause of these ejections is currently debated. Some possible explanations are volcanism, geysers, tidal friction, large impacts, or collisions with Saturn's E-ring. The E-ring, which is made of ice, is the outer ring of Saturn and collides with the orbital plane of Enceladus. Volcanically induced geysers inside Enceladus would explain the heat rising from the tiger stripes. It is likely that heat is transported to the surface by advection of warm water vapor rather than thermal conduction. If the plume is generated by sublimation of water ice, then temperatures of 180 Kelvin would be required beneath the ice.
The crater density in the southern hemisphere is lower than in the northern hemisphere, telling us that the surface of the southern hemisphere is younger. This lack of craters shows that the areas near the South Pole have been resurfaced recently. Crater counting near the South Pole indicates that this surface is less than 250 million years old. This is surprising because crater counting in the northern hemisphere gives us an age closer to 4.5 billion years ago, which is about the age of the solar system itself.
Spencer et al. Concluded that Enceladus' eccentricity was different in the past, causing tidal heating to be more of an influence. The past orbital eccentricity of Enceladus may have been enough to produce tidal heating at such a rate. This may heat up the base of the cryosphere, which is the surface layer of ice covering Enceladus. Tidal heating is the process by which gravitational forces from Saturn pull on one side of Enceladus, while other bodies pull on the opposite side, creating heat by the extension of the equator and the compression of the poles. Complex networks of ridges and troughs on the ice agree with tidal heating stretching the cryosphere.